Hello everyone, my name is Manjunath S Makari and I am doing this heat apps assignment for Skyfi Labs, which is based on heat apps for tall structure analysis. Firstly, go to File, New Model. Here, use built-in settings with metric SI Indian for steel section database and steel design code IS 800 2007 and concrete design code IS 456 2000. Go for it. Okay, then the number of grid lines in x directions which we have is 1 2 3 4 four numbers in along x direction and 4 numbers along y direction. The spacing is equal, that is 6 meters, both along x as well as along y direction. Number of stories which we have is like here. The number of stories are 23 and the typical story height and bottom story height is found to be 3 meters. Okay, then grid only option, go for okay. Then wait until it loads. Okay, we have got this thing. Now first go to edit stories and grid system. This modify show story data. Here there are some similarities in certain plans as well as their member assignment. So firstly, when we see from story 1 to story 8, the whole thing is similar. So we can choose any one story and make it as a master story. So if we make this a master story, then we must keep similarities between 1 to 8. Therefore we can make this as story 8. Or we can keep any among 1 to 8. Then next set of stories are from 9 to 14. From 9 to 14 we can set this one as a master story. 9 to 14, remember this is a 14 story. Same way. Next is from story 15 to 19. 15 to 19. Story 19. You can check this 19 and 20 to 23. Yes, these are all default. 20 to 23. Okay, so all 3 meters, hence the elevation is going to be 69 meters overall. Just cross check once. This is similar to this. Okay, from 19 to 15, 19 to 15, then from 14 to 9, 14 to 9, then 8 to 1, 8 to 1 is the case. Okay. Next, we need to define the materials. Go to define material properties. These are all the default values. So add new material, choose India. We first need concrete. First need concrete, India. Then the grade is M40 grade of concrete for high-rise structure. This all specified data will remain the same as it is default properties. Then add new property. Now we need rebar Indian HYSD 500. Okay, this is for main reinforcement. Then add new material HYSD rebar Indian. Here we require mild steel for stirrups or confinement reinforcement. Okay, now define section properties like frame sections. So if it is confusing you, you can go delete it. Okay. Now add new properties. First we need to define the sections. Like first we'll define the sections of beams. Beam 300 by 500, 300 cross 500. Material is M40, depth is 500, width is 300. Then modify show rebar. Here design it as a beam HYSD 500. This is mile 250. Can keep this thing as 25 to 30. I'm keeping 25 for cover. Okay, 300, 500. This is one group of beams. So add a copy of property here. Beam 350, 550. 350, 550. Okay, you can see here the width is 350 and the depth is 550. You want to check this thing. Okay, add a copy. Beam 400, 600. 400, 600. That is M40, same thing. 400, 600. Now add new property, auto select list. Beam sections. The concrete numbers. Add it here. Okay. Next, add new properties. We want to define the columns now. Column 500, 500. Leave it as M40. 500, 500. Reinforcement column main is HYSD 500. Milestones 250 to be designed rectangular. Okay, this is the default one. Okay, Okay. Column, add a copy of column 550, 550. Then 550, 550. Check it once. Thing is fine. Okay. Add a copy of property. COLUM 600, 600. 600, 600. Okay. Now we need to prepare auto select property for columns also. Add new property, auto select list. COLUM column sections. Add. Okay. So after defining all the frame properties, define slab sections. Slab 1, modify slab of 150 mm. We want to provide a grade of M40, shell thin slab 150 mm. Okay, slab of 150 mm is provided. Okay, now slab beam column is done. Now we need to draw quick draw beams or columns. First see in which story you are, then similar stories. Which is the beam section. You can use the beam sections. You can see here. Next, in the same way we can provide the columns also. What is the column part? It comes to here. Okay, then slab 150. Use quick draw. Okay, it's up to 8th story. We can go to 9th story. Quick draw beams, beam sections. Okay, where all the beams according to the given assignment properties. Quick draw beams, beam sections, frame. Okay, the beams. Okay, Next, now go to quick draw columns, column sections, from here to here, from here to here, from here to here. Quick draw slab 150. Done. Now move to the above floors, just cross check once. 10, 11, 12, 13, 14. Okay, now again quick drop beams, beam sections, and beams. We need to go for quick draw columns, column sections, continuous. Okay, nice. Now go for slab 150. This is for story 15. Then cross check from 20 to 23. We have only this part 20 to 23. Now what to do is again go for this thing, beam sections, quick draw beam sections, draw even these portions, then quick draw columns, column sections. Column sections are also only this. Slabs 150, 150. Done. Part is done. Next, drawing or modeling part of this structure is completed. Now we need to apply the loads. Okay, now similar stories, select here up till 1 to 8 we have a dead load of 2 kN per meter square. Okay, define, assign shell loads uniform dead load of 2 kN per meter square. Apply. Live load of 5 kN per meter square. Okay, now go to the 9th floor. From 9 to 14 we have a live load of 4.5. Apply. Then for the same thing we have a dead load of 2. Apply. Done. Next, go to the above story. Here comes the story 15. So select this and provide a dead load of 2. Okay, same way select this and apply the live load of 4. Okay, next can see here 8 shells and 32 edges. We have a live load of 3.5. Apply. We have a dead load of 2 kN per meter square. Okay, this part is done. Now we need to apply the cladding load of much 0.2 kN per meter. It's a distributed load. Okay, go to the bottom story. Select only the exterior beams on which cladding load will be acting. Be careful that you won't select any interior beams, so otherwise it will take into your design. Okay, total 252 frames are selected. Total 252 frames. Assign. Frame loads distributed. Dead load, gravity, a uniform load of 0.2 kN per meter. Apply. You can see here. Just go to the top part where there is no load acting. Select this, go for display, undeformed shape, and you'll get this part. One story, go for only one story. Select, assign, frame loads distributed, delete existing load, apply. Okay, display, load assigns, frames, apply. Okay, can check. The same way, display, load assigns, shell, dead, apply. Everywhere we have the loads. In the same way, it will be having live load also. So column section is right. Done. Next is modeling of E-tabs is done. Assigning of loads is done. We need to draw the claddings. Auto draw cladding, use floors. Okay. Now we have assigned the dead load as well as live load. Now we need to define the wind load and apply to the claddings as well as to the whole building. So go for define load patterns. Here type it as wind load and type of wind. Indian code is IC 875 2015. Okay, select it, add new load, modify lateral load. Now according to the code IS 875 Bangalore, consider the building to be situated in Bangalore, and Bangalore is having a wind speed of 33 meters per second. Okay. And terrain category, it comes under terrain category 3. Then importance factor is taken as 1, as it is importance factor is taken as 1. There is coefficient factor K1. When we consider the risk, that is consider the building to sustain for around 50 years, and we take K1 is equals to 1. And the topography factor, as there is less slope there, less than 3 degrees, hence take K3 as 1. Then apply OK. Now we need to assign the wind coefficients to the claddings. So first go to elevations, select A, apply. Now here take it as all stories, and when we see the code book, when we see the code of IS 875, there in the plan it has been given A, B, C and D. Along the A side it has the coefficient of 0.8 windward coefficient. And how we check it? When we go for IS code, we first need to find out the total length or height of the structure, that is 23 into 3 meters will get a 69 meters. Width is 18 and length is also 18. So H by W ratio gives us 3.83. Then by finding the suitable in which it falls, suitable portion in which this value of 3.83 falls, and there are two subcategories into it where W by L ratio is taken. So here W by L ratio is 1. So again select a factor where the ratio is between 1 to 6 or 1 to 3 by 2. So select that portion. In that portion, for A side of the plan, we have 0.8. Select that portions. OK. Then assign shell loads wind pressure coefficients. After assigning, we have a CP of 0.8. Windward side, apply. It shows the values. Okay. Now select this. Now on the opposite end, that is windward end, we need to select because this has an irregular plan. You can see the windward portions are here, but when you go to these portions, the windward portions are here also. So what we need to do is go for elevations, go to section B, apply. Okay, then select all these things. Windward of 0.8, apply. Next, elevation C, I'll explain you this first. Go to plan, see these portions are B, that is when in the given code book the whole rectangle, if we consider a whole rectangle as a building, this portion is A, this is B, this is C, and this is D. But here, due to plan irregularity, what it comes is, this is A, this part is B, this part is A, this one, this one, this one. Okay, in this direction it comes as A. Now B is this one, 1, 2 as well as 3. Same way we have it in elevation C as well as in D. So go to D, elevation D, then apply a levered coefficient of minus 0.25, then D, first select it, levered coefficient of minus 0.25, apply them. Now go to C, all stories, select them, and levered of minus 0.25, apply. Okay, now the portion comes is, when we see the code book, we have a portion A is done, B is done. Now C and D, they both have a coefficient of minus 0.8. okay, it has a coefficient of minus 0.8. so we need to go for elevations, where it is apply 1, that is it's the elevation along this side, that is along these portions, 1 along 1. You can check it here. We have to, it varies as the plan varies. Okay, here we have 3, the same way it is in here 3, here 2, here 1. So select, go to this elevation, 1 1 1, all stories. We have a wind coefficient of minus 0.8, leeward side, it will take automatically, apply. The same way they all have the same value of minus 0.25. so go to second elevation, select them, apply. Third one, apply. Sorry, select only the shells, minus 0.8, apply. Fourth one, select 0.8, apply. Okay, and okay, this is the wind pressure coefficients, wind load is applied. Now one more thing I forgot to do it. Select the base, only the joints, assign joint restraints, okay. Here you can see the fixed support link. Now the next step is for design, okay, analysis and then design. And one more thing you can check in the plan, and we go to the story one and apply, or go for plan. We can check the values which we have given, windward as well as leeward coefficients. Go for 3D. Then we can check the extruded view. We have extruded the frames. Then design, concrete frame design, view preferences, check whether the design code is IS456-2000 or not. If it is not, then please check it and change it. Next, log the model and run the analysis. (14.05.2020). As it is a high-rise building, it takes some time to run. Just you can see the values due to which, or you can just remove that extruded because it takes more time. Okay. It is the displacement due to dead load, surface due to the displacement. Okay. Okay, because I have run the dead as well as live load cases also, so it takes time. Now design, concrete frame design, start design check. Remember that we have given here auto select properties. So in this case, if the member fails, then it will take a higher sections automatically. See here the sections 705 concrete frames are failings. You want to reiterate, means it will take initially it will take the lowest section, then go for design. Then once the member fails, it will try to take the higher member from the list, and again a reiteration takes place until and unless the given sections passes the design check. Now see, sections differ for one concrete frame. Do you want to reiterate? Yes, reiterate it. Only one member is failing, so it will reiterate and fix that problem. It will optimize the sections and give the best probable design. Think the design is complete. Now go for design, concrete frame design, verify all members passed. Hence that it comes, all the concrete frames are designed and they pass the design check. So we can go to display menu, deform shape. We can see the dead load, live load, wind load, and its displacement values. Here you can go for user defined also. Draw contours, use it, apply. I can check the displacements and many other things. Okay, display undeformed shape. Then go to define or display forces and stresses diagrams, frames, shear in two direction. Okay, frames, apply. This is the shear force diagram. Moment along 3 along means this is the bending moment. Okay, thank you very much.